All right. Welcome to TestWizardry. This is day 3 of our course. And today we're going to put into action the basics. We have our Java development kit enabled, which allows us to compile and run Java programs. We have Eclipse installed, and I hope that you've gotten a little bit familiar with that if you weren't. And today we're going to jump right in. We're going to cover some of the details of the Java syntax, talk about the keywords, curly braces, and how objects are put together, as well as primitive variable types. And then we will get started on implementing our Harry Potter game. So let me just jump ahead to where we're at, right? We've talked about the Java compiler and virtual machine, the language. So the syntax starts off really basically, right? We have expressions. An expression is anything that evaluates, and addition is an expression, 1 plus 2. A simple statement, true or false, is also an expression. A variable is an expression. Combining variables is an expression. A statement consists of an expression, such as a variable assignment or whatever, that's evaluated and ends in a semicolon, right? So let's take a look at some examples, and I will just bring up Eclipse here. Here's the teaser of the game. Let's just create a new Java file. So I'm going to create a new Java class, and I'm just going to call it Java syntax.
Hey Aaron, you are still sharing the PPT, not
okay.
Eclipse.
So let me see. Let me try new share. I thought it would switch. Maybe I just need to minimize the PPT to see it. All right. Do you see Eclipse now? It should say
Nope.
public class Java syntax.
Nope, still the PPT.
Okay. All right. How about now? Public class Java syntax.
It just popped up.
Package TestWizardry. Okay.
Yep.
Great. Okay. So now you can see I've got just my editor taking up the bulk of the screen, and I'm going to go ahead. Ooh, that's a little bit too big. That's my magnifier. You know what? I'm going to trying to control Windows from a Mac when you're not familiar with the differences, the vagaries of that. All right, so let me go back to my Mac. I'm going to open Eclipse on Mac. Maybe that was part of the problem, that it was using the Parallels VM. All right, I believe the next slide is, okay. Yeah, we'll talk about keywords in a minute. First, I want to show you expressions, statements, comments, and so forth. Okay, so we've got all of our hello stuff, right? Oops, clicked on the wrong thing there. Okay, so in my default package, I want to create a new Java class, and I'll just call it Java syntax. I'll call it examples. All right. So the first thing I've alluded to that I haven't mentioned before is comments. Now, a comment in Java, this is a comment. A comment is something that is ignored by the compiler. It is there, just there for you to read as a person. So it's to make things easier. There's also another way to write comments. So you start off by doing it with 2 forward slashes, makes it a comment. You can see the syntax highlighting in Eclipse turns it green and doesn't fail to compile because it's ignoring it. The other way to make a comment is you do a single slash and then an asterisk. This is a multi-line comment. And the idea here being that I can write a comment that's multiple lines by using the /* syntax. Both work the same. The difference is I would have to for multiple lines, I'd have to do that. Whereas a single multi-line comment. Multi-line comments typically, by convention, have 2 stars at the stop or at the start and on a blank line. And this is used for JavaDoc documentation. And the idea being here that you can do that, and you can even do things like you can add annotation. And, you know, if I have a method called, you know, and then it's just going to return false or whatever, right? So this is a JavaDoc style comment that it describes what it does in 1 or more lines, and then it can do things like describe multiple values. But let's not worry about that for now. I just wanted to point that out. The next thing is an expression, right? One example of an expression is 1 + 2. That validates. You can see it doesn't underline. Let's eliminate this. I just don't want to have any squiggly underlines. That will distract Java syntax examples. Oh, that won't work because it's not in a method. That's why I was getting that error. All right, so let's jump back. So everything is in a class, and everything in a class except a variable declaration is in a method. So that's where you get the public static void main. Right, and this is just kind of something you memorize. Another thing to point out is that there are shortcuts for doing things like creating a main or creating system out print line. For instance, if I want to print something and I don't want to type system.out.println, I can do sysout, and then you can see what I did is on my Mac I did control space, and it changed sysout to system out println. There's a bunch of quick little shortcuts like that. And then in Eclipse, for knowing your shortcuts to do things like, say my formatting's off, something like that, and it will reformat it. If I do Command Shift F, it reformats it in a cleaner, neat style. I want it to be a multiple line comment. All right, I'm not going to fight the system. It wants to reformat my string for me. All right. So getting back to expressions, right? 1 + 2 is an expression that evaluates. Every statement contains an expression or assignment or something like that, right? Now here, 1 + 2, it says, oh, no value, right? Invalued assignment. I can't make a left-hand assignment. So what I would do is I would do int a equals 1 + 2. A is my variable name. So jumping from expressions, well, I want to show you a few other expressions, right? I can have Boolean B equals false, and I can have string C equals hello world, right? And I just wanted to show you to introduce a few types. So this expression evaluates to 1 + 2, obviously 3. False is a statement by itself, right? 1 is an expression by itself. False is an expression, but we could also do Boolean means true or false, named after, I think, Charles Boole, scientist from way back. I can say 1 is greater than 2. This will evaluate to false. Well, let's change this to 1 is less than 2, which will evaluate to true. And I can put a comment here that this is true. I can also work on appending strings together, right? So I can do hello plus world, or hello plus name, as you've seen. If I have a variable named name, of course, that works. And let's go ahead and, oh, looks like we've got someone to admit. So we've got several things going on here. We've got expressions. Each statement consists of one or more expressions that are tied together, right? I can do 1 plus 2 plus 3 plus 4. And I can even make it greater than 7. Now, this is going to fail because now this expression evaluates to true or false, not to a number. Change type to Boolean. We don't want to do that. So there's some examples of different expressions. Now, every statement has a semicolon. Let's hop back over here. Parentheses. Now, you may remember from math, your math expressions might have 1 plus 2 times 4. What is this going to evaluate to? It's actually going to evaluate, you would think 1 plus 2 is 3 times 4 is 12. It will evaluate to, if you remember your order of operations, 2 times 4 is 8 plus 1, 9. But we can use parentheses, just like in math, to change our order of operations, the precedence. So now it would do 3, 1 plus 2 in the parentheses, remove the parentheses, and return this. So 1 plus 2 becomes its own expression, and then times 4 would give us 12 for an expected value. You can do the same thing. I could say 1 is less than 2, or now these two pipes, or let's use and 2 is greater than 3. Now this needs parentheses to evaluate correctly each expression separately. Now what I'm saying is D will be true if both of these other expressions are true. If 1 is less than true, that's true. And if 2 is greater than 3, so that actually evaluates to false in that situation. But that's getting a little more complex than we need. I just wanted to show that expressions can be layered together. So an expression, a statement, variables, method names, and class names, and our keywords are all case sensitive. Keywords should all be lowercase. So for instance, I can have a word called static equals whatever I want to assign it to. Actually, it looks like it's going to complain about that. Oh yeah, I need to give it a type. String static. So because it's uppercase, it's not a keyword. Although it's probably giving me a warning about that. And then the next thing I want to show, I showed comments, right? Single line comments, multi-line comments. A comment can be at the end of a line, and anything after that, right, is still going to be a comment. And you can see that in green on Eclipse. These are all things that it inherits from C, the programming language, back to Algol. Class has curly brackets at the start and the end. Same thing with a method or function, has curly brackets. A function has arguments, showing here. The parameters or the arguments are put in parentheses as well. I could create another function called public int add 2 numbers, and it would take 2 numbers, right? Int A and int B, separated by a column, oops, or separated by a comma. And now I have 2 arguments. I could even do add 3 numbers, although I'd probably want to change the name of this as well. And then I would, define that. I can return A plus B plus C. And now we've got a working method. An expression can also be a method call, right? So equals add 3 numbers, 6, 7, 8. Well, because the main is static, it can only reference a static other method, which is why that error was coming up. Another thing to point out is that white space is irrelevant. I can indent this as much as I want. I can put spaces right here. I can put spaces between the commas or not. Any spaces, extra lines, tabs, new line characters, they're all ignored by the compiler, except in the case of a literal. For instance, 1 and 2, that's 2 numbers, but that is 1 with a space with a 12. Likewise with a string, well, it just treats a space as an extra character in that string. All right, let's see. Oh, and the last thing I want to do on the syntax is brackets. Now, we haven't talked much about arrays except for our example of arguments, but you can see here that these brackets indicate that it is an array. And when we reference args sub 0, meaning the first argument, it uses those brackets to indicate the number of the element in the array. So that's pretty much it for the general syntax, right? The syntax errors. If you remove a semicolon, you're going to get an error. If you remove a parentheses, you'll get an error. In this case, it'll say insert parentheses to complete. The errors may be more or less useful as well. If I remove a bracket, it will also complain. Insert closed bracket, square bracket to complete the argument list. And then it can't understand the rest, so it's giving me another false error. Same thing if I remove a parenthesis or a curly brace, I'm going to get an error. Expect curly brace expected after the parentheses token. And that's type thing. Also typos. If I misspell something, Boolean or Boolean cannot be resolved to a type. It's nice that you can see all of these things because Eclipse is compiling and printing these errors and putting these little markers in place as I type, which really makes using an IDE nice for writing Java. You can see these other little icons, these yellow ones with an exclamation point and a light bulb. Here, if I hover over it, it says the value of the local variable A is not used. And I think that's what all of these are. Yep, B is not used, C is not used, etc. So this gives you hints. You can also, hopping back out of the full screen view, you can see it in the problems view. I see my warnings, same things. And if I have an error, I might have to hit save to see that. There we go. I've got a syntax error, insert semicolon. So these errors and optionally the warnings are what you would see on the command line after you type Java C and execute. It would say error semicolon missing on line 14 or whatever. All right. Now back to a little bit more theory. Keywords. There's a whole bunch of keywords. You probably recognize some of these, and even if you don't, you might understand what they're for. Others are a little more esoteric or opaque to understand. When you're doing control structures like we've first looked at, an if statement. If this statement is true, do this, else do that. If and else are keywords. Likewise, when you do a loop, a for loop, for is a keyword. When you do a while loop, so right, for each item in a list, or for that expression int I equals 0, I plus plus, whatever. For is a keyword in that loop, and each thing in either a loop or a condition, right? So a for loop or an if statement has curly braces as well. So we can come back in here and we can say if a greater than 10, we would put brackets and we would do something in that if statement, right? System out, print line, whatever, right? Else, system out, print line, Maybe we want it smaller. So each of these is a block inside parentheses, just like an entire function or an entire class is a block separated by curly braces. One other thing, if we have a for loop, that also takes a block. And you would do something out here, and then you would say system out print line I maybe. And I'm not even going to run this code. This is just to show the syntax and the keywords. An alternate way of writing a loop would be while I is less than 10. You can do the same thing. So the problem we have here is one of scoping. You can see here it says I is not declared. I cannot be resolved to a variable. So what I need to do is I need to declare an integer of I, because I is only defined for the scope of this for loop. It exists only inside that loop. I can actually do it outside as well. So I could declare I above that. And I could do that. I could actually leave out the assignment here. But to be explicit, we'll do that. Now, for I equals 0, I less than 10, I plus plus. When we get down here to line 43, or oops. I'm going to take all of this out of the add 3 numbers because that's probably confusing. And I'm going to create another function. Oh, it didn't give me my bracket, and then it did. All right. So if A is greater than 10, what I'll do is I'll pass in, let's pass in I, just to illustrate. Now, if I is greater than 10, it says it's bigger. Otherwise, it says it's smaller than 10. So now we don't need to declare our I because I has been declared as a parameter to the loop, or a parameter to the function. So we can again declare another value here, but it can't have the same name, right? So instead of doing that, we'll just we'll set I equal to 0 here. Now, in the while loop, because we're using this external variable, it's already going to be 10 by the time it completes the for loop. So it would never get to this statement, which is why usually in a for loop, we give it another name. And by convention, we use I because it's an integer, because it's an iterator, and because it's the index of any array. And then by another convention, which means you don't have to follow it. It's just commonly done. We could use another variable called j, because j comes after I. And that's common in like mathematical expressions as well, that you would choose, you know, a, b, c, or I, j, k, or x, y, z sequentially like that. And here we go. We've got while I is less than 10. Now, we've got a couple things. A while loop is simpler than a for loop, but number one, it doesn't initialize the value. And number two, it doesn't do anything to the value. Here in our for loop, we're both initializing j here, and we're doing a comparison, and we're incrementing it, in this case post-incrementing, j. So what we would need to do to make this while loop work is we would, well, let's run this and see what happens. And in order to run that, we would need to call our function. And we can do that itself. This is, what's my error? It's not static, is it? No, it is public static void. Oh, we're expecting a value. We'll pass in 1. That's right, I changed it to have a parameter. And so when we run this file, it's not going to do anything with all these other statements up here because it's declaring them, it's saving it into memory. I've got an error. Index 0 out of bounds. What did I do? For length 0 on line 14, I can click here and it'll go to line 14. Well, I don't have an argument. So here's what I'll do. If args length greater than 0. Another thing I can do is if I have a single line block like that, I can do it on the same line. Let's try this again. So what we've got here is we've got an infinite loop here in this while loop. While I is less than 10, it's just printing 1, 1, 1, 1, 1, 1, 1. Well, it starts at 1, it stays at 1, so it never gets to 10 and it never gets bigger. When you do that, what you can do is you can kill it with Control-C or Command-C. Or you can hit this stop thing. I guess here I wouldn't do that. I would hit the little red square for terminate or stop, and then it ends. So what I want to do then in my for loop is I want to add a statement all by itself, I++. And I don't know if I've covered this in detail, but I++ is the same as I equals I plus 1. So I equals 1 plus 1, 2. And then the next time it goes through, it would be I equals 2 plus 1, which is 3. And then I equals 3 plus 1. And it goes through all that. In our for loop, we've got J, right? So let's run it again. So we see here, it starts off and says it's smaller than 10. And then it goes through the for loop to print J, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we start at 0 here, but I, if you remember, up above, we passed in the number 1. So it's not actually starting in as 0. It assigns 1 to int I. Int I equals 1 is essentially what it's doing in this case. And I just wanted to do this for adding more information, just so we don't lose track of what we're looking at. All right, so we run this again, and it shows my console output. Well, that gets a little bit ugly. So what I want to do is I want to put this before my loop starts. I don't need to print that every time. And we'll call this while loop and for loop. There we go. So we've got our for loop, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, because J starts at 0. And then our while loop starts at 1 because I equals 1, and it goes up to 9 as well. Now I can do I equals I plus 2. and now it will go 13579. I can also express that as I plus equals 2. And that will do the same thing. Or if I want to do plus equals 3, it should do 147, yep. Or plus equals 4, 159. It's a little faster at math than me, and so forth. You can do the same thing with minus equals. Although in this case, we've got us an infinite loop that's going to count down by negative numbers. 1 minus 2 is negative 1, minus 2, and so forth. Let's clear that output. All right, so that really doesn't make sense to do it that way. So let's see, going back to, let's look at more of our keywords. We've looked at our if, else, for, and while loops. A do while loop is the same as a while loop, except you say do something while a condition is not true. Now, the obvious, and then it has a semicolon on the end. The obvious difference here is it performs the check after it let me admit someone else. It performs the check after it evaluates, or I mean, it evaluates the expression after it performs the block of code, right? So in the case of a while loop, it gets up to 9 and it fails. Now it'll go up to 11. It doesn't. While I is less than 10. Oh, because it evaluates 9 is less than 10, and then it doesn't matter. If we started off with I equals 0, this would show me that it would get up to 10, or 0, 2, 4, 6, 8, and then it would get up to 10 and stop. As opposed to a while loop would actually go the other way than a do while loop. All right. So we've got some other keywords. Switch statements, we're not going to get into that. A switch is like an if statement, except it takes multiple values. We'll show that later. And then we have all of our types, our variable types. Our integer types, it means whole numbers. Int, a long is a larger integer. A short is a shorter integer, only 16 bits. So up to, I don't know the numbers, smaller number. And a byte is actually an integer type as well, which is 8 bits. A floating point number essentially means a decimal number. It has a floating decimal point. So a float is single precision decimal, and a double is double precision decimal point, which helps to avoid rounding errors. In some cases, you still have them though, unless you use a math library. So we have, typically what we'll use is we'll use int and double, unless we know we're going to go, like over 2 billion or whatever, then we'll use a long for an integer. To use a short or a byte is usually done in the case of you want to save memory. Now, a char or a character, it means a single letter, number, punctuation character, or a space, tab, or new line character. A Boolean, as you've seen, means true or false. So those are all keywords, as well as these other things, declaring a class, a package, or an interface, which you can extend, implement, import a class. You can refer to this, meaning this object, super, meaning its parent or super object. You can create a new object, modifiers like public, private, abstract, final, static, synchronized, transient, volatile. And then when you're dealing with exceptions, you try, catch, throw, and finally handle an instance, whether or not an exception is thrown. Instance of tells you, is this variable an instance of a string, for example? And you can use asserts. And there's a few more that are newer that we're not going to go into at all. So those are the Java keywords. A keyword like while or for or int is reserved. You can't create a variable or a class called int or while or return or any of these other keywords. Variables have two phases, although we usually look at them together. You declare a variable and then you assign it a value. So you declare a variable by giving it a type. We'll go back up to our top here, right? So int a, we give it a type, int or integer, whole number, and a is its name. The type of b is Boolean and the name is b. And then we also have the value here. In this case, it's false. I'm going to clean up my formatting. The string type of the variable named name is Aaron. And what we're assigning here is there's three ways you can assign a variable. You can assign it a literal value, like this literal string Aaron. You can assign it a literal true or false value. And you can see also that true and false are keywords. And then you can also assign it a literal number value. Now a number value might be a floating number, right? So, and that might be 1.25. What's wrong with this one? Add cast to float. Oh, is it a double by default? Interesting. So it wants you to use doubles and not floats all the time. So you can see that if I want to create a long integer, right? Now, that isn't quite long enough. Now it's going to say that this is actually an integer, but I can force it to be a long by adding an L. Likewise, I can do the same thing with a short or whatever. But I don't need to go into all that. An actual long number would be something huge like that. That's too long for a long even. What is it? Is like 2 billion or something? And it says out of type int range. So what I can do, if I add one more decimal place, it should give me that error. I can add an L, and that essentially makes it a long. Let's see. It doesn't give me a hint. My internet's going to be really slow while I'm broadcasting. I probably should have just gone to primitive types. All right, so I think that might be actually too long. I'm not going to count the decimal places. Well, I'll do 1, 2, 3, thousands, millions, okay, billions. So if I go 2.2 billion, that's too big, right? There we go. But 2.0 has to do with the number of integers you can store in 32 bits. I'm not going to figure out the exact number here, but it's somewhere slightly north of 2 billion, between 2 and 2.5 billion. Let's see. Back to the slides. So we've got our literal variables, right? A string in quotes, an integer, a float, a Boolean, and you just saw a long. And we're not going to go into math.java, but I will post that on GitHub. And there's an exercise for using the debugger, which we'll go into tomorrow. The different types. I've kind of covered all of these, right? We've got our numeric types, our whole numbers, int, and then a long integer and a short integer to either save space or fit more length. And then we got a floating point or double. Like I said, typically you'll use int and double, with the exception that when you need larger numbers, you'll use long instead of int. And when you want to save space, because it's, you know, it's going to be something small under 65,000 or something like that, for a short number. Say you're only going to iterate to 10, you could use a short and use less memory. And then we've got our strings and our individual characters. One last point to make about characters is that a character type, which I haven't put any here, char, I'll call this one Q for lack of a better word. When you create a single character, you use single quotation marks instead of double quotes like you do with a string. So a literal character is single quotes, a literal string is double quotes. And the reason that it does that is a character is actually an integer type. And character A is actually 63, right? So I think it'll print the numeric value, although it might cast a character to a string. Character A is 12. Oh, because it's the variable A. Character A is A. If I did A plus 0 and put it in parentheses, though, it'll change it to a number. And that number, I believe, is 63. 97. Oh, capital A is 63. And that has to do with the ASCII ASCII. Let me see. 65. Okay, I was wrong. The ASCII standard is a very old way of looking at numbers. On older computers, they created 128 characters. There we go. Wikipedia might come to my rescue again. And it shows here that character number 65 in decimal is character A. So 64. What I could do is if I do A plus 1, it should say character A is 66. And if I change that to, that's not going to work. Here, let's do A plus 1 up here, and then we can do it like that. So now we know it's a character type. A plus 1 will be B. Character A, A plus 1. Now, if we change that to a minus, what is that going to be? I don't know, but it's not going to be a character, or it's not going to be a letter. It is a backtick. And the capital A minus 1 I saw is character 64, and it is a @ sign. And you can just see that from the table. 65 minus 1 is 64. Character is @ sign. If we did another minus 1, it would do question mark on down the list to greater than, equals, less than, colon, etc. And so let's see, lowercase a minus 1 is this little backtick. You probably can't even see that. But anyway, that's character data types. That's the last thing I wanted to cover on that. Oh, nope, it's not. Arrays and objects and collections, we'll get to those in the future. We've already seen an array using brackets for the arguments. We've talked about expressions, loops, conditionals. I think we've gotten through all this before, and control structures, break, return, continue. That probably bears a point here. You can see here this add 3 numbers, and let's go ahead and add some output here. E is, oops. Now 6, 7, and 8. Quick, 21. Is that right? E is 21. Now the E colon, that's just a string, a quote. And then the plus, remember only strings apply this plus. You concatenate the strings or make them into one string. You join them together as opposed to doing addition math. Anyway, so a return type from a method. Now you can see this method, instead of having a return type of void, has return type of int. This add 3 numbers. It takes 3 parameters in its argument list here in the parentheses. It works on them by returning them after it adds them together. So we can be explicit and say in parentheses, it's returning them all together. Or we could actually do int d equals a plus b plus c and just return d. Return, again, another reserved keyword. You can see it very easily in the Eclipse editor, which is one reason having an IDE with a fancy compiler, text editor working together. Anyway, it returns the value, and this is the last type of expression, is it calls a function and returns the value of that function here and assigns it to this. So it would actually, and this is kind of how the compiler works, not exactly, but it says, okay, D is A plus B plus C. Great. We'll take A plus B plus C here. We'll do return A plus B plus C. And then we'll take A plus B plus C and we'll put it up here on this line. So we're actually saying E equals A plus B plus C. And then if we look again here, A is 6, 7, and 8. So E is 6 plus 7 plus 8, right? And we can actually go even further. We're kind of compiling it by ourselves here. And we said E equals E plus 6 plus 7 plus 8. And then we can actually change that. So we can say E colon 21, and we make it all a string. And that's how the computer works. It takes all these things and it kind of puts it together. It says, okay, this is 6, this is 7, and this is 8. D is 6 plus 7 plus 8. Return 6 plus 7 plus 8, return 21, etc. And the compiler does this in advance, which number one makes it more efficient because that's a lot of steps to perform every time you run it. It can do it all at once. But here's where variables come in, right? Programs are made up of 2 types of things. Number one, steps or procedures that do this and then do that and then do the next thing and so on forth, right? Add 3 numbers, return their values, and then print them. That's a simple program. But it consists of 2 things, the steps and the variables. And variables are what make programs more useful than calculators. A calculator is you're entering numbers and putting them. A variable is, well, the word variable itself means change. It varies or it changes. So a variable in common usage, right? Someone who doesn't know any programming at all, if you say, what are the variables? They would say, well, we will get to the restaurant, or if you ask the question, when will we eat? Well, there are a couple of variables in that. Number one depends on when we will leave. Number two depends on when the restaurant brings us our food. And then you might have some other variables that are outside the scope. And this is where bugs come into program. Things like, well, how long does it take to get there? Traffic is a variable, as well as, well, maybe you have a friend who sometimes is late and sometimes is early. So their arrival time is a variable. And that makes sense in common English parlance. In programs, variables are these things that you don't know at compile time. In the case here, when I assign a value 6, 7, and 8, and I just add them, I only have a procedure. I don't have any real variables there. I mean, they're variables in the sense that I declare a type and a name and assign a value. That's the definition of a variable, but they don't change. And in fact, the Java compiler will say, wait a minute, this is always going to be 6 because it's literally 6. And in this case, we mean literally. So it's always 6. So I don't need a variable called a. I'll change it to 6. And likewise with 7, that never changes. I can keep that 7. And 8, that never changes. Well, D, 6 plus 7 plus 8 is 21. D is always 21. So then I'm like, well, I don't need to keep track of D either. As a matter of fact, I know that this function called add 3 numbers always returns 21. And well, it doesn't always return 21, but in this case, it will always return 21 because these are literal strings. But now I have a function that can be used for different things, right? Int f, well, actually, I can actually reassign e, and I can add 3 numbers, and I can do, I don't know, 3, 28, and negative 19. And I'll print it twice. So what I'm going to do here is I'm changing e, and this is kind of an ugly program, but the point I'm trying to get through today is helping us understand the syntax and the way variables and variable types work today. This is not by any means a pretty program. And it's doing a bunch of stuff we don't need to do. And here's another nice thing. I can actually comment out a line that I don't care about. I'll actually comment out all of this stuff. Oops. And now it all turns green, and it will actually ignore all of this and just run the part of the program I want. And this is, oh, I've got an error. Oh, it says it just wants to save. Click OK to always save. So here we've got, when we add 6, 7, and 8, it will print 21. When we add 3, 28, and negative 19, well, that just so happens to be 12. So we can see here that a function suddenly, like a mathematical function actually, that's what it's based on, but a function has this attribute of reuse that if add 3 numbers was called go out to eat, and it returned how long it took before dinner time, or maybe the function was called when's dinner, and it returned the time, that we have variables. We could create another function called public static. We could even return a date and time. And we're going to return something. And it's going to be a date time. And local date time, that's what I want. All right, so when is dinner? I create a function called when is dinner. It's going to tell me the time. But there are some variables. I want it to be at now. There are some variables like when we leave. We'll just use ints. Another variable is, we'll use this as an int, how long it takes to cook. And another one, how long is traffic? Maybe how slow is how much our waiter likes us. And we would add those to, and that's not going to work. I'm kind of pseudo coding because plus can't add a date and an integer. But you get the general idea that that's how you would write a program that answers a question when we leave, or when is dinner, and the variables are so forth. So that's all for today. if you have any questions or comments, we can go ahead and take those right now. Once again, I didn't get as far as I wanted, but I'll go ahead and give a teaser. Switching to my other Eclipse in Windows. What I'm going to do is I'm going to post this program on the GitHub repository so that you can download this program or copy it yourself and run it and modify it. And we'll look at it in more detail tomorrow. Here's that Java syntax with bad spelling. But we've got this TestWizardry console, and what I'll close with is I will just close with running this very simple interactive. I don't even know if you could call it a game yet. But what it does is it brings up a console. Here we've got it full screen. I'll make it a little bit bigger font so we can see it. Oh, I'm running into magnifier issues again. Okay, I'm not going to make it bigger. It says TestWizardry. Welcome to TestWizardry. What is your name? Well, I'm going to type my name and it shows up in the console. It would do the same thing from a command line window. It says, what is your last name? My last name is Evans. Hello, Aaron. Tell me a bit about yourself. Are you male or female? Well, I'm male. And since I'm male, you're a wizard. How old are you? Well, I'm 45, actually. I don't like to say it. That's too old to start wizardry school. How old are you really? Well, anyone who knows their Harry Potter trivia knows that you're admitted to Hogwarts on your 11th birthday. Not everyone has a big guy with a beard and a motorcycle deliver them a cake and turn their cousin into a pig or give them a pigtail. But when you're 11, you're admitted to Hogwarts, and it says, well, happy birthday and congratulations. You've just been accepted to the Hogwarts School of Witchcraft and Wizardry. Dear Mr. Ms. Evans, I suppose I could change the template. It knows I'm male, so it can say Mr. We are pleased to inform you that you have been accepted to Hogwarts School of Witchcraft and Wizardry. Please find enclosed a list of all necessary books and equipment. Term begins on 1st of September. We await your owl by no later than 31st of July. Yours sincerely, Minerva McGonagall, with an extra L, it looks like. Deputy Headmistress Hogwarts. But there's no time to celebrate. You need to reply via owl post and get your supplies. It's off to Diagon Alley with you. So this is the start of the text game that we'll be developing. And it's available for you to look at the source code. And it only uses a few things that we haven't been taught so far. And one of those is this scanner, which will read system input. Almost everything else, well, it has an enum value of. That's kind of tricky. But go ahead and look at this, and we will walk through this code tomorrow. So take care and have a good day.
Thank you.
Thank you. Bye.
Goodbye, everyone.